Hey guys, today we are picking up and we are going to try here to finish off some of the last, I don't want to say conceptual, but a kind of loose ends here before I send my friend off to go practice a lot of problems on his own, asking me questions if he gets really stuck. We've decided that that's the best approach for kind of developing the skill oneself. Watching someone do it is a little bit different than doing it yourself. Being able to figure out the problems on your own without always having to have your hand held. Well, that is really kind of the important part because that's what you get hired to do as a programmer on a job. Not that you never have to ask other people for help, but that, you're self-sufficient enough that when they pay you to code, you actually code rather than always not being able to. That's where we're going to move forward. But I said, I actually added one right before we started here. So I was going to talk a little bit about pseudocoding and test-driven development. And the reason why I included this after talking about pseudocoding, we already kind of discussed this a little bit. And I don't want to overly belabor the points made here because I know I've talked about it some before and the pros and cons to planning out more things when you program versus kind of winging it and then reorganizing your code as you go. It's not a wrong answer. Like I said, it depends on personality and what makes the most sense to you and things like that. Maybe what I was thinking of, I was trying right before I rolled this to remember. I thought there was one other thing. I think what I was going to do was have an example of breaking down. So pseudocoding is one thing, but then why would we want to do it? Like, what's the case where it kind of makes sense, where even people who don't plan as much will want to do it? I don't think we'll have the time, nor have I thought of a very complicated example just off the top of my head before going into this. But these are just some, like I said, loose ends to tie up here before we shift into practice mode. And we may well be in practice mode for at least a couple weeks, if not more. It's going to depend on basically how fast we get, because some of the exercises that we've been going through here, they're certainly not. What's the best way of putting this? Like, for most people in most introductory programming classes, these things are at the level of projects or the assignments tasked over the course of like a week or something. It's not like they knock these things out every 15 minutes and then you get another one. For introductory programming, these things we're not like going at a snail's pace is what I'm saying. We're actually going pretty fast, at least compared to the pace of instruction that I received when I was in college classes. Nonetheless, I'm not going to sit here and arbitrarily say, well, we have to go thus and thus rate. If you manage to get through a lot of the practice problems and you start picking up speed, and you start being able to do the problem in 10 minutes rather than maybe 25 or 30 or whatever, well, then I'm not just going to sit around and have us stay there because obviously that means you're ready. As things come together more, we will move into advanced topics eventually. But I want us to sit here and stop and take a breath. So some of the topics we still have left to talk about, Lambda functions and generics, and then object-oriented programming in general, and database stuff more specifically, and then web applications. We have a link for a Django tutorial way up there. I'm still kind of debating if we want to use Django. Django is pretty big. There's a smaller web framework called Flask. Kind of what I want. I want to figure out the simplest way to get an HTML, JavaScript, and CSS, so a front-end page. I want to find out the easiest way to get a front-end page connected to Python code. I'm actually not convinced Django is the easiest way because Django is probably the most feature-rich functionality-based way. It has the biggest probably user base in production Python web applications and lots of tutorials and support and stuff. But I kind of just want something that lets me, have an HTML page that hits a Python controller and that's it. I'm looking to Flask more. I haven't really done that much research on it, but anyway, all of this stuff we will get to. I don't even know exactly where the finish line is for us, but I would say once we get through most of this stuff, you're going to have, general programming knowledge. The other thing here, actually, let me even preface this stuff. we're just shifting into planning mode here for a few minutes at the beginning of today before I go ahead and finish off everything there. We should also download Python, set up environment, and then we need to talk about virtual environments and everyone's favorite part of programming, distribution control. That's one thing. Oh, this, okay, I remembered. So I couldn't remember what it was that I wanted to bring up. And what I wanted to bring up was version control. Now, we're still not going to do this right now because we're going to finish the things that I listed out above right now. So it wasn't a today thing. It was something that I wanted to make sure that we didn't forget. And that is version control. And specifically, we'll learn Git because that is the version control tool used, at least by most teams. There are other ones. There's another one called Mercurial, then Subversion. And there's some differences between these, but Git, G-I-T, probably has by far the dominant like market share, if you will. Not that you pay for it. All of these software packages are, free, openly maintained, but Git has the largest user base. Well, that's a better way than market share. And so we will talk about Github, which is an online, I'm trying to think about the best way to explain this without actually explaining version control. It's a place for Git repositories to live online, to host your code, basically. We'll talk about visual Git tools. We'll talk about, let me do the command line Git process. I personally use visual Git tools a lot. Specifically, I use an application called SourceTree at work a lot. Now, GitHub has its own thing that's basically SourceTree, but GitHub's version. I think they're basically the same thing. I don't think it matters that much. And then we're also going to talk about merging and so if this all sounds overwhelming, like, oh no, Stephen, you're adding even more information. Yeah, don't worry about it. The reason why I'm so happy I remembered that it was this is because this is really, really important. This is one of those things that I never learned almost anything about in college, and I really, really, really wish I did. Because when you work on a team, if you fly solo, you should still version control your stuff. It makes it way easier to roll back if you mess something up, to go back to known state in your project where everything worked before you broke something. But on a team, it is by far, I don't want to say the most important skill, but one of the most important skills. Oh, and even on top of this, we can do software development. Sorry, I keep coming up with topics. I keep coming up with things I want to know that I would have wanted to know coming out of college that we didn't learn about in college. And since that's kind of the goal here, that's the overarching principle of this is, programming in the real world, TM, like I'm not advertising this or whatever, but, like that is kind of the gist of what I would like to provide in this, what sets it apart and all that jazz, is trying to come up with the, like the knowledge and the experience base that is legitimately useful in preparing people for actually working, rather than having some theoretical dusty knowledge of it. A legitimately useful working knowledge of everything you need to do to be successful. And not just successful, but, contribute to your teams, feel like you're being valuable, things like that. So talk about Devops because it's free and I know Devops. We'll let you pick. You definitely want projects. I'm a hypocrite. I didn't coming out of college, but I did have a college degree. And for people without college degrees, suddenly your resume and your projects become that much more important because you don't have a piece of paper to fall back on, right? But all of this is future. Like I said, we're just getting a little bit off topic, future state here. But I'll flesh everything out eventually. Might seem kind of overwhelming, but I mean, it's all the sort of stuff that you don't think of, that they don't teach you. That's actually sometimes the most useful. Okay, so yeah, the Git specifically was what I remember now. This specifically was what I wanted to make sure I didn't forget about, that we do it eventually. So anyway, all of that's future. So we have these things down here: a database, web app stuff, specifically object-oriented programming, Lambda functions, generics. These are all more advanced programming concepts. Like these are like code stuff. And then all of this stuff up here is not code, it's the rest of the stuff. So dealing with your development environment and your packages and stuff, this is critical to building larger software systems. If you have just one script, I mean, you still have to deal with packages and import them and stuff, but it's not the same. But if you work on an enterprise level application or just even anything that gets bigger, you have to know how to do all of this, because otherwise it will become unmanageable very fast. Okay, well, I'll stop rambling about all of the stuff that's coming, but I'm actually legitimately happy that I remembered what the thing was, because now it won't bother me either. So today, like I said, tying off the initial loose ends we have here, and you know what? I should add testing formally. We're going to add unit testing formally to the eventual to-do agenda as well. Today, we're just going to talk about it. So I don't exactly recall how much I've waxed eloquent to you about unit tests and why they're necessary and useful and stuff. I certainly have to my poor younger coworkers who get stuck with me, because it is my duty to inform them and inculcate them in the ways of our team. I don't know why I ended up as one of the training people, but I did. And so new people all the time ask, well, why do we have to test our code if it works? That is exactly the question to ask. Is like, why do I have to write code to test my code? My code does the thing. And so like, isn't writing a test to do it? Like the customer doesn't get functionality from the test. Like, why do we do it? What's the point? So unit tests are not for the customer. Unit tests are for you, because let's say you come around and in a few months when you're rusty, you don't remember exactly all of the specifics of this bit of code you wrote, and then you need to go change something. Well, let's say that code that you change, this particular part of the project you're working on, let's say that it affects something else and you didn't think about the thing that it affects. And so when you go and you make your change, maybe it's not that hard, you change the name of a variable, or you change the return type of a function or something, and then suddenly something somewhere else on your site breaks. And if you don't have unit tests, you don't know about it. If you don't have tests for your code, you may not know that by doing one change, suddenly it's trickled. Specifically, you know what? That's testing in general. I'm actually giving you bad information. That's integration tests. Unit tests are supposed to be testing functions specifically. So they're at the level of functions. You remember I've been arguing that in our code organization, functions should be as dumb as possible, basically. And so they should do one thing and one thing only, and should have a limited purpose and scope and things like that. I will pick up with what I was just saying in just a moment here. I realized I was shifting into the wrong topic. Unit tests specifically are at the function level. And so in the example I gave, if you change the return type for a function, well, that's not a good example there anymore. This would just be like, if you expect your function to do a set of things, like let's say you expect your function to take in a name, add the person who the name corresponds to the database, and like give their records some initial values or whatever. If you change some of that and you don't have something that tests what you were doing, if you have like a set of, in agile software development, we call them acceptance criteria, a set of things that your code is supposed to do, and you change your code, you want to make sure that after you've made your changes, your code still does all the things it's supposed to do, right? And you can go through and you can test that by hand. It's possible. But each and every time you make changes to your code, do you want to go through and test everything by hand? because, like I said, you could, but you want something to be automatic to test it, right? And that's where unit tests come in. Now, I think I'm explaining the unit test part of this better. We'll get to integration tests again in a moment. Now, I will tell you, most people are lazy, at least I am. And when they say quote unquote unit tests, they mean tests in general, not just tests at the level of functions. But I don't know, I won't exactly type it out. I mean, you can Google all of this. I'm saying general programming knowledge. I'm not feeding you opinions and stuff here. This is like how it is, facts about the universe. So the point about unit testing is that for us to be sure that our code is doing what it's supposed to be doing, every time we make a new change to it, the only way that works that isn't crazy time efficient is to automate the testing of our code. Because again, if you were to say that humans have to manually test it, sometimes things get very complicated and the code that you write changes a lot of things. And then you have to go test everything, or you would if you didn't have unit tests. Now, let me be clear that actually nothing's going to stop you from writing code without unit tests. The problem is that at any given point, if you don't have unit tests for all your code, you're never sure that when you make changes, you're never sure if things still work. They could. And in fact, if you go through your application happily and you don't see anything broken, well, then maybe nothing's broken, but you're never sure of it. You cannot sign on a line saying that my application does this set of things and I'm positive of it, because you're not verifying in code that you're positive. Now, sometimes unit tests can give people a false sense of security because they're like, well, I have tests, my code must work. Well, if you always make the test pass, if you always make it like return true, get the green check mark, but it doesn't actually test your code, it's useless, right? The whole point of tests is for us, it's to let us know that if I change something and my function is no longer doing what it needs to do, it's no longer meeting the criteria of acceptance, the things and side effects it's supposed to have. Well, if it's no longer meeting criteria, I want to know about it, because if the whole point of the software system is to build something that meets a set of functional requirements, which in the production world, like if you're building something for someone, that is almost always the point. If you're working on like frameworks on the bleeding edge, maybe not quite so much, but in general, you always want your code to be doing something, and you want to know that it is for sure doing something rather than just kind of sort of thinking it might be. So that's unit tests. Now, integration tests, I will be more formal here because I should be. Unit tests are at the level of functions. They're saying, does my function do what it's supposed to do? Integration tests are more or less along the lines of, okay, I changed something somewhere, and I've now tested that the change where I made the change is okay, right? Does the change break other things somewhere else, things that are related? I'm trying to think if there's a better way for me to explain that. It's kind of like ripples on a pond. If you change something somewhere in your code, since everything tends to end up somewhat connected anyway, it's possible that the change that you made somewhere ends up breaking something else, even though you didn't change any code in the other place.
Yes, I understand. I think the example that the example we worked on yesterday, I think that proves it, because many functions that were removed from the main program, if anything changed there, it would change the way the main program would work. Mm-hmm. That might seem to be an example of what you're saying. So if anything is changed in any of those sub-functions, we'd like to make sure that it doesn't change the way the main function works. Or if something is changed in the main function, we want to make sure it doesn't affect the other functions as well.
Now, the lines get a bit blurry, even to myself. I don't want to give you wrong information. I will tell you that the most typical things that integration tests do is they test the interfaces between things. And so if you have a user who's supposed to be importing a certain kind of file, right? The integration test is making sure that the file is imported correctly, because then the rest of it is just stuff going from function to function. It's kind of traceable. Integration tests, now, you know what? like I said, I don't want to give you bad information. The difference between every single time someone explains this to me, I get it for a little bit and then I forget. And I'm not saying it's not important. Part of the problem is that our project is very, we have a lot of schedule pressure, which means that it would be great if we had all of our ducks in a row here. So unit testing is a testing method by which individual units of source code, well, that's very vague. Usually it's functions, like I said, or classes, where integration testing checks integration between software modules. Well, thank you for telling me what the words mean. Perhaps I'm being too harsh on that person, but you know what this reminds me of? We have a tracking current. I'm going to go off on a tangent for just a sec here. We have current and historical values in our application. And one of my coworkers asked, in our main chat channel, hey, what does it mean when this thing basically gets set to historical? He's asking in their process, what happens when their data gets archived? Like, what does that mean conceptually? Who does it? That sort of thing. And then one of my other coworkers responds, it means it's no longer current, which is like, it's obviously that's not what the other guy was asking, right? He wasn't asking, hey, why is, what does it mean for something to be historical? It means it's not current. Well, gee, thank you, Mr. Obvious. Anyway, yeah. Sorry. It still makes me chuckle when I think about it. And then, of course, he posts back like the skull and crossbones, just like, okay, I'm dead. You're toxic. Okay, so unit testing. Here we go. This is more what I was looking at, a table of comparisons. So again, okay, testing each module of the software separately.
Okay.
I knew unit testing is performed first. So you make sure that each thing individually works before you test that everything works together. But before system testing, so there's more. I don't want to get tied down in the icky specific details. Okay. So, yeah, it says that integration testing is performed by the tester, so it's not the developer. But you can have automated integration tests here. The lines get kind of blurry. I don't want us to like block here and get all confused about the words and what they mean and stuff. But basically, unit tests are what I worry about most. They are what you will probably worry about most too if you're a software developer. Some poor people have to go figure out how to do the more complicated business of testing how things integrate. You can sometimes do that somewhat automatically. There are applications that will help you test your code, like not as in like the automated test that we'll get to eventually when we talk about it formally, but things that will actually like press the button at this location on the screen after a 5-second pause, things like that will actually help your application do a certain set of steps in a certain order, which anyway, I don't want to get too off topic, but after you make sure that each individual thing is right, that's the first step, because if you can't even guarantee the validity of the pieces that you're using, well, obviously when you stick them together, you can't guarantee the validity of that. But guaranteeing the validity of that is, it's kind of another step on top of making sure that the functions themselves are right. So I won't overly belabor the point other than saying that testing is very important. I will also say testing is very unpleasant. Most developers don't particularly love it. I mean, like, you have to do it. There are good reasons most of the time why we're supposed to do it. Now, let me think about the best way to phrase this. I think that the opportunity cost, this question is actually up for debate. It's not on my team. We have security regulations where I work and things along those lines. That means that we can't get away with certain sets of laxer standards. However, one thing that unit testing is it's time intensive. Depending on the complexity of the code you're trying to test. I know I'm being really vague right now because we haven't actually looked at any unit tests, but eventually we will. I'm just talking in general. The complexity of the test can be such that it can take you almost as long to write the test as whatever the actual code you wrote was, if not longer. And remember that the end user they don't benefit from this at all. They don't get anything out of the unit test. And so if speed is your priority, and if you have experienced developers, and if your requirements are flexible enough that if something doesn't meet requirements immediately, it's not like the world's going to crash and burn. If those three conditions are met, in my opinion, unit tests are more optional. Because if something breaks and you have an experienced development team, it's not going to sit there and you're not going to be doomed because someone will figure it out rapidly enough. But suddenly you have downtime. You have a period of time when your application isn't doing the right thing. And so for kind of critical infrastructure applications where you have to have 99.99999 uptime reliability and the application can't just not be doing the right thing, that's not ever a viable option. Well, then you're going to have to say, you know what, guys, we have to test. We have to test everything because we need to be sure that everything's working at all points in time. But if you're a little bit looser in your standards, you say, guys, we don't have to unit test. And that probably saves more time because it's more efficient for the developers to only fix things that they figure out are broken than to go through and make sure that everything is correct. Does the statement I just made make sense, or do I need to say it again?
Say it again.
Okay, so it is a lot more time efficient for the developers to only go through and fix the things that they figure out are broken rather than go through and make sure that absolutely everything is correct. So let me give you an analogy example, and this should help. So when I had my new house constructed, it was about 6 months ago at this point, somewhat less, the builder came through, and it's not like they were trying to build a bad house for me. You know, it's not like they sat there and they tried to cut corners or whatever. But how this process has worked for me, since I have a home warranty through my builder, is that since the time that we closed on the house, when we closed on the house, the deed was transferred to me. It's now officially my property, not their property anymore. But since that time, I have been able to contact them through the warranty service for the house, and I've had various things fixed. So I had a towel bar that needed to get put up in a bathroom. Actually, they didn't quite put it up right, so they're going to have to come back and do it again. Some paint applied to an area where there was a mark on the wall. This was something that we'd pointed out in the pre-closing inspection for the house, and it just didn't get done. A cracked window due to supply chain issues that was going to be replaced, a screen door that's catching, not quite closing properly. There was a problem with the initial plumbing. So plumber came out and fixed it. There was a problem with the initial HVAC system. I'm not trying to make it sound like my builder is bad. They're not. They fixed everything in a timely manner and professionalism and all that great stuff. But the point is that if they had had the time up front to go through and check absolutely every single thing in the house. So I figure these things out because I'm living here full-time 24/7, right? If they had done it, it would have been possible for them to have caught everything that I just told you, right? However, for them to do that, they would have had to pay someone hours and hours and hours and hours to go through absolutely everything in the house and make sure that there's zero issues whatsoever. Yeah. But if I come to them and say, hey, Mr. Superintendent, sir, here's a small problem. Can you send a guy over to fix it? And he goes, okay, sure. He'll be there. Okay, when's convenient for you? They only have to fix the problems. Now, if you're paranoid and cynical, you can say, oh, but doesn't that mean that there just may be problems you don't know about? And here's where the practical realist side of you needs to come out and say, but if I don't know about the problems, can they hurt me? You have to trust people to a certain extent here. So in my case, I have to trust my construction company. I have to trust the builder of my house. And one of the reasons why I'm okay with that is because, they have lots of very good positive reviews on Google. They've been around in the area. They're a local builder. They're not just going to go out of business or pack up shop and move away so that you can't sue them or whatever. They're reputable, which means that this process that I'm talking about, the fact that I bring issues to them and they fix the issues, from a business perspective for them, it's great because it means that they only end up spending time on things that are actually wrong. They don't have to spend time on things that are right, because no one gets value out of spending time on things that are right. And so I don't want to sound here like I'm dissing unit tests. I know we're talking about all of this conceptually to begin with, so we don't have examples in front of us, but I just want to get you thinking about it because it's important. Yeah. And I also just want to introduce the idea that there is kind of an ongoing debate in the development community about the utility of these things. No one questions that they're useful. If we could have 100% code coverage on unit tests all the time. Every single piece of code you write is tested, has to be tested. Then it would mean that you always know whether your code is doing what it says it's going to do or not. It's completely deterministic that way. That's not the question. So the question isn't whether or not they're useful. The question is whether or not you get enough value out of them for the time that it takes you to write and maintain the unit tests as well. Is that time worth the time that you save by knowing that things are broken? We will revisit this. We will revisit this topic. Let me come over here specifically and make sure we talk about code coverage when we do. That's an important part of it. Because they will serve as warning bells and tell you when anything goes wrong. But that whole long analogy discussion that I just brought up was that it is a more costly way of doing things, right? You are guaranteed to set yourself and your code to higher standards because you always know that it's doing the right thing as long as you are testing, appropriately. So you always know that it's meeting a perfect set of acceptance criteria and standards, but you pay a big, steep time cost to guarantee that. And if you can get away, as I say, if you can get away with not having them, and by get away with, I mean, if a bug happens and you get good information to a team of experienced developers who've seen it all before, generally, you will have some downtime. The developers will have to patch things that are wrong. They may miss a thing here or there, but it's not like your application will be, just doomed if a bug gets into release, because the team can be responsive and fix it rapidly. And it means that development cycles may be a lot shorter. It only works, as I said, for people who are more experienced, and also if your application doesn't have as stringent requirements. So they have to basically be okay with having a bug here or there. And if you're okay with having a bug here or there, it doesn't mean that you get a shoddy product. It just means that it's a slightly different set of circumstances. So if you work on things like financial systems, they're not going to be okay with you having bugs, right? That's not okay. Or if you work on the security infrastructure for a government, right? You can't have a bug in like the source code that is dealing with secret information, or even corporate secret, not just government secret. Something where you have cybersecurity. Cybersecurity people can't afford to have issues in their code. But if you're making a website for a client and you want it to do various things based on the data that they store, and let's say that you have a page that's supposed to display, I don't know, like let's say you're building a website for a florist or something, or a web application for a florist, and you want to be able to sort and filter various kinds of flowers, and you messed up your function for sorting by color. And so even though you say it's sorting by red, it's really sorting by like red and pink both, not just red. Well, the florist is going to come to you and be like, Mr. Developer, I tried to sort by red, but I got a bunch of pink flowers too. What's going on? Can you fix this? You want to know what? Like, if the florist can't sort by pink flowers too, is life going to stop? I don't know if this is the best example. I'm sorry for all the florists out there, but that's not the same as you not handling security information properly, or not the same as you messing up a financial transaction so that someone gets paid more or less than they should, or a transaction doesn't go through or something. All of those things are huge issues. And in the grand scheme of things, this will be annoying. It's never nice. We should always strive to never have any bugs in our code whatsoever. But if the floral shop is on a budget, guess what they can get away with? They can say, you know what? Every once in a while, maybe the code doesn't sort on pink flowers. However, I was able to get a software product that basically meets my needs for 40% less money. I don't actually know if that's how much unit test costs, but it wouldn't shock me, right? I'm able to get something that gets the job done with an experienced, one or more developers who can kind of just sit there and knock it out for me. And basically we get to that 80-90% threshold for a lot less time and money. Sometimes that could be the right answer too. Does that make sense?
Yes, it does.
Okay, well, I'll stop blabbering here then. So we won't actually do the example of breaking down a problem, I'm going to talk a little bit more about pseudocode here. So if you remember that website I shared initially, Code to Flow, ever since I've come across this website, I almost don't pseudocode on paper anymore. And the reason for that is because if I can pseudocode and have pseudocode and have it build a flowchart for me, pictures are almost always better than words for programming. The problem with pictures most of the time is that it takes too much time if you have to sit there and drag like boxes and stuff by hand, which is unfortunately how most flowchart software works. This is not the only one. Before this, I was using another one that like converted text to a flowchart. I like this one a lot better because this is very much pseudocode, right? So
Yeah.
this text right here, it's like 5 lines, right? Super easy for a programmer to write. It generates this pretty picture that helps you understand exactly what's going on, right? So in flowcharts and pseudocode, the diamond here represents a decision, right? So you see there's a true path and a false path. If you pick true, you go this way. If you pick false, you go this way. But this, versus reading a block of code, this is really easy to understand, right? So first you come to the website. If you're in doubt, you press help, right? So if in doubt, you press help. And then once you're ready, you can go read the help if you feel like you're still not ready yet. And if you are, then you can go ahead and use the application to improve your workflow, right? And then if you're not in doubt, so you feel like you got it already, you just jump straight to this step, right? That's what this has done. Very easy to explain. And in fact, you see this has a loop here, right? Because you're going, and then, you see that if you're not ready, you keep going, right? That's a while loop. Represented very clearly by this flow with the direction of the arrows, because code execution is directional. So, I'm not going to overly belabor the point. I think I've talked about pseudocode the last couple of lessons and how it can help you plan out what you're going to do in what order, how to break down problems and stuff, but how, in my opinion, and I'm speaking from a professional sense here, not just personal, it also, if I'm going to go to the bother of writing things out, so it's very similar to the code, why don't I just write the code? That's usually my opinion of things. Now, usually what I'll do is I'll kind of stub things out. So usually you'll get a feel for this once you've programmed more. Usually the thing that is difficult and time consuming isn't necessarily the general structure of the program. It's usually one or two specific things. So for me specifically, we work with a big enterprise level database. Usually database stuff is what takes a while. You have to figure out which tables do I need to join and get stuff from, and this query is gross. I have to filter on a bunch of things, and the database stuff can get pretty hairy pretty fast. But the general thing of hey, I want to get a list of user records, and then for each user, I want to do something. You could write the loop for that now, right? That's not hard. You just loop through stuff and you do something for each one. Once you've been a programmer, you can do that in your sleep, right? Once you've been a programmer for a while, you can do that in your sleep. So a lot of the time, in my opinion, sitting there and writing out a pretty pseudocode that makes the picture and stuff, like I said, very much recommend this website. If you can pay to afford it, you can even host the things, and I think you can even embed them in iframes and stuff. But really like this site, think it's very clever. And it really helps make pseudocode that much more valuable if you're trying to explain something to someone else. That's the other place for pseudocode. So pseudocoding for yourself, useful in situations where things are so complicated that you need to wrap your own head around them. But for a lot of day-to-day structure, it's fine to get the structure in place while leaving a couple to-dos. That's typically what I do, is if I am trying to envision the shape of the code in my head, how am I adding this feature or functionality? What I'll do is I'll write most of it without it compiling. I'll try to get rid of red squiggles if I can, but if I can't, whatever. What I'll do is I'll get most of the stuff there. So I'll have that loop that goes through customer records and does things to them. But what I won't do is I won't write the line that actually gets the customer records. I'll say customer records equals blank list, right? And I know that I have to write a big icky SQL query to get all the stuff for the customers. But I'm not going to do that right now, because I want to make sure that in my head, I have how everything else is going to work after that, right? Because I know that's going to be time consuming and take me a while, but I don't actually need that to get the rest of the structure determined, right? However, is that pseudocode? I don't know. I mean, I'm actually coding the rest of it. I'm actually using proper programming syntax, something that will eventually compile in the language. To me, that just saves time. Seems like it's efficient, right? Why would I write things twice if I can just write it one way the first time? But as I mentioned before, pros and cons, right? Now, I will say that one area where pseudocode comes into its own is if you're just trying to explain it to someone else, right? I think this is especially true, not so much for your coworkers. If you ever work on a team, you will have other software developers on the team with you. You guys will both speak code, so to speak. You know, it doesn't matter what programming language it is. You're programmers. You know how things work. So if I say like, oh, well, in the while loop, you know, you're indexing into the index-based key to the person's name, and that has a foreign key to blah, blah, blah. They're going to look at you and they're going to nod. They're not going to look at you with glazed over eyes and be like, what is this man talking about? I have absolutely no idea. However, in almost all organizations, the organizations are not run by programmers. They're run by people who have experience in business management, which is logical, you know, because by and large, it's not that programmers will be terrible at business management, but like that's not what their expertise is in, right? They're good at writing code, not necessarily good at making business decisions and figuring out customer expectations and all of the other complicated bits that go into like successfully managing a software business. Well, the managers, at some point, you're going to have to explain the code to them because they're going to have to make decisions, or they're going to have to make a pitch and then make the customer make the decision. But at some point, you're going to have to explain what your thing is doing to someone who doesn't code. You see what I'm saying? Like, you can't use the language foreign key and iteration and callback function or anything like that. You can't use those words because it's not going to mean anything to those people. So in some manner of speaking, it's way easier for you as a programmer to talk to other programmers because they speak your language. You don't have to like sit there and figure out how you simplify everything. I mean, actually, sometimes you do. If you have newer coworkers, people who aren't as familiar with your process and stuff, same problem, right? It's basically like you're trying to explain your code to someone who doesn't understand code. And when you're trying to do that, that is when it's not important what it looks like in this programming language or exactly how things work. You can just wave your hand and be a little bit magical about it. Well, when you're trying to explain things at that level, that's when pseudocode is very helpful. That's when I really like the flowcharts too, because I can explain this to someone who doesn't know a lick of code and they'll still understand more or less what it's doing, right? I don't even have to explain the arrow means this or whatever. Like most people have seen a flowchart before in their life. They'll get it immediately. And you shouldn't underestimate that because your job becomes a lot easier if you can explain what you need to the people who can get it for you. I don't want to like humble brag, but I think this is some place where I do okay. You know, I have a couple other team leads who I think are better than me at some other things. You know, so for one thing, some of them are just have a lot more development experience than me. I'm still pretty young, but something that I feel like on my particular team, we have like 12, 13 developers or something. Of all of the people, I'm one of the ones who's better. I mean, there's other people who are probably about as good as me, better at taking the issue that we have and explaining it to someone who can actually get us the help for it. Hey, boss, you know, like we have this thing, it's blocking our work completely. We need the customer to address this point. And then I have to like explain in the process where we're stuck, what information we need, stuff like that. It's kind of like a learned skill, right? Some people are just going to be better at it than others because there's some people, one of my coworkers, one of the stronger developers on our team, he hates making decisions. He says, just tell me what to do and I'll do it, but don't make me like think about it. You know, if you say, hey, go implement this, as long as I give him a set of requirements and criteria and stuff, he'll just put on his headphones and he'll hammer it out. And it's great because I know that if I give him something, it will get done and he won't like mess it up. However, he doesn't want to try to explain it to normies. That sounds super harsh, but like, he just doesn't want to. He likes to keep his head in code land 100% of the time. And this is kind of what I mean about different people being good at different things. You're going to have to figure out eventually. I have no idea where you'll land, but you'll have to figure out which kind of person you are, right? And if you're the kind of person that can take it and make that connection with someone who doesn't speak the same language, you will probably end up in kind of more of a position like where I am, where I help organize work for our team because I can kind of speak both business perspective and code perspective. I can bridge that gap a little bit. Some people don't want to bridge that gap. It's not where their strengths lie. And that's good and acceptable. No one's better than anyone else, right? It's just different places in the project hierarchy. In some ways, I'm a little bit envious of the people who can just live in code land all the time, because sometimes they end up being better developers. Like they're so into it that they see all these technical connections and stuff that I have to work at. I have to sit there and squint at it and wrinkle up my face and not understand for a while before I get something, where sometimes they just blink and then they've got it. And it, like I said, not better or worse, just different. On the other hand, not to get too sidetracked, being able to speak in a non-technical way, huge job skill. A lot of programmers, I don't want to be mean, a lot of programmers don't have the best social skills. They aren't able to do what we're talking about. If you can, puts you ahead, right? It means that you're suddenly a more limited asset because not everyone can. So one of the ways in which you do that, like I said, pseudocode flowcharts as well. This life hack, okay? A lot of people don't know how easy it is to generate something like this. At least I didn't, because a lot of people will think that you sat there and you did it by hand, right? If it takes you 10 seconds to make in a program like this, but it looks really impressive is what I'm saying.
Yeah.
Okay, well, that's that for pseudocode. The other thing that I was going to talk about then is test-driven development. And the reason why I didn't talk about this when we were doing unit tests specifically was because test-driven development requires you to ascertain the structure of your application up front. Put quite simply, test-driven development means that you write the unit test for your code before you write your code. Let me say that again. You write the unit test for your code. You write the tests that specify my function should do this, so that when I give it this input, this happens. When I give it this input, this other thing happens. If I give a division function, 0 as the second operand, it should return a division by 0 error. That is the expected outcome of it. That's the behavior that I expect to happen. Well, if you set all of those rules up front, so what you're doing up front is you're saying, I'm going to, in code, I'm going to say that my function does this thing, and it does this thing, and it does this thing. Well, if you set your test up correctly, then it means that when you actually run your code, then you'll be able to know right off the bat whether or not your code works. TDD, very, very useful in some context. However, it forces you to program in a very specific way. So most specifically, you have, I don't remember what they call it. I think usually they say red, green, refactor. That's the terminology used for test-driven development. First, you want to make the test fail. So you've written your unit test. You've already written your unit test, and now you're starting development. The first thing you want to do, if you have a function that's supposed to take in 2 integers and add them, the way to get red is to not do that, right? So to take in 2 integers, and then rather than add them, you subtract them. You want to make sure that you see the test fail. Otherwise, it's possible to write a unit test where you just like always make it pass, which doesn't help you test anything, right? You want to make sure that your unit test fails when it's supposed to fail. And then you want to make sure that it passes when it's supposed to pass. A really easy way to do this for our example of a function that takes in 2 parameters, let's say takes in, number 1 and number 2, just like our add function does. Well, if you call a function with both parameters 5, then you'd expect the return value to be 10. So rather than worrying, maybe I didn't do the addition correctly, what if you just hard code 10? You say, no matter what you give me in that function, always return 10. Well, then when you return that function with 2 5s, you are guaranteed that your test will pass, right? And so now you've tested to make sure that when your code doesn't do what it's supposed to, the function is sure to fail, that when your code does return what it's supposed to, your test is sure to pass. That means that you wrote your unit test correctly. This is the gut check way to test. Is my test testing the right thing? Once you've done that, then you actually refactor your code to make it do what it's supposed to. So in this case, if you hard code, the return value of the addition function to be 10, it's not always going to be right. So what you need to do is then write the function how it's supposed to be, AKA it takes in the 2 arguments and adds them. And then you want to test code based on that. So after you've rewritten your code to actually basically make it more generic, to make it not just hard code pass, but to pass, doing what it's supposed to do, then suddenly, you know, after having gone through this process of writing the unit test first, then making the unit test fail, then making the unit test pass by hard coding something. Generally, that's what you do to get the green check. And then writing your code how you're actually supposed to and seeing if the test still passed. If you've gone through that process, this means that at no point in your code process will you ever be uncertain of whether your code works or not. Now, if you're tracking, you probably see the problem with this up front is that this imposes like a super rigid hierarchy on how you do things. Like you have to do this and then this and then this and then this. And if you don't do it, then you're wrong. It's hard to get a dynamic, large group of people with diverse perspectives to buy into this, to drink the Kool-Aid, so to speak. Because if you can set it up, it means that your test will always have excellent unit tests. It will always have good code coverage. It will mean that anytime something breaks, you'll be able to instantly say why it's broken. In general, it also requires a bit more of an experienced team. They already have to know how to unit test stuff. Because if you tell people, hey, you need to unit test everything, and they say, what's a unit test? You know, you got problems, right? And unit tests are not the same as coding. You do write unit tests in code, but they have their own set of things that you need to know to do them properly. It's easy to do them improperly too, is the problem. But why I'm bringing this up after our pseudocode thing is that how, you remember when we developed this function here, how many functions did you think we were going to write up front, right? I mean, I couldn't even tell you this question, right? You know, maybe I could have, maybe if I'd sat there and thought about it for a while, I could have told you, okay, you know what, we'll probably have a function for add, subtract, multiply, and divide. We can break that up, right? Some things it's kind of easy to see the structure of how things are broken up. But would you have been able to tell me right off the bat, you know what, we're going to make a function and we're going to pull it out, and that function is just going to get a number, right? It's just going to get a number from the user, because that's what we did. We wrote a function to do that, right? And you do get better at this over time. That's the sort of thing that, you know, here, if we were to write the pseudocode for this, what we would have had was, you know, user starts app, and then after that, you know, user picks operation. You know, that's not the best way to think it. Sometimes my brain spaces out for a second. So we're going to talk about all the different cases here, right? So if we needed to write tests up front, we don't have that luxury of writing it and then making more functions as it becomes obvious we need to pull them out, because we should have written the functions testing like all the functionality before we wrote a single line of code. You know, we would have to do this for add, subtract, multiply, divide, right? Divide like this. So build out a tree here. All right. So of course, I'm not actually giving it useful things here, but this is what the code in our application. And then if we put the else here, you know, goodbye. That's what we made our application do. See how this works? Now, this part, maybe I would have been able to tell you up front that this is how our application was going to work, right? However, past that, to be able to successfully unit test all the code up front, I would need to know that I was going to have a function that, you know, like the main function here that switches between these. I probably could have told you this one. I could have gotten this one. Inside of the functions here, to be able to properly unit test it, you would have to know that you were going to get two numbers in the function and then return the addition of the two numbers. You'd have to know that up front to be able to test it properly, because you'd have to write tests for it before you even wrote this function. And then you have to know that this function you were going to organize it so that it called another function that then got the numbers, right? You'd have to know before you wrote any code that you were going to make another function to do this. Is that impossible? No, it's not impossible. You can get better at this too. People who do this, teams who do this, they start thinking much more upfront about how to break things down, about how to design their code well. In fact, it has a certain set of advantages because what it forces you to do is you can't be sloppy. Because if you're sloppy, you can't even think about it, right? Like you have to be pretty rigorous in how you break things down and how you organize your code because you have to test things before you write any code. So I'm bringing up TDD. My team is probably moving this direction. We have a tech lead on our team who's come on, bless her heart. She's trying to organize our project because I don't want to say we have a bunch of cowboy developers, but it has kind of been the Wild West for a little bit. You know, we've been under a lot of schedule pressure. And so, you know, things have gotten done because they work. And no one questioned of, is this the best way to do it? Or will this be maintainable in 10 years in the future? We'll just shrug and be like, well, you know, we got it done within the deadlines, you know, like, and that sort of attitude will get you into trouble eventually. And so test-driven development, red-green refactor, pseudocoding things out beforehand as much as you need to be able to figure out the function structure before you write code so that you can write the unit test for it, has the advantage of you always knowing your code's testability, of you always being sure of that state. And the reason that's why I put it after pseudocode is because you need to be able to understand what's going on in your process, what's going on in your functions before you can break it down to be able to test it. All right, do you have any general questions about all of the stuff we've talked about? I know today's been kind of rambly. You know, I haven't even looked at any code, but you know, all of this stuff's important for, you know, the organization of code on projects and maintaining that code and things like that, which I know I've said before, but that's like the bigger part of software, of the software development process is maintaining code, not writing new code. All of this is related to that. So.
Yeah. I don't have a question right now. I thought after this, I might just read up a bit on all of this and maybe I will have some questions then. Right now, everything makes sense to me as it is. I understand it.
Yeah, I mean, and you'll get more of a feel for this once we actually do tests. You know, I'm just doing this up front, you know, just because I think it ties off the conceptual bow here to our introduction to writing functions and dealing with functions. That's kind of what we've been doing, right? We've been doing so-called functional programming. We haven't done classes and stuff yet. We've done functions and loops and all that great stuff. And so how do you test it? How do you know that your code's right? That's why finishing off here, it's a good place to end kind of our introductory foray into programming. And we will get into actually writing unit tests. Yeah, we'll do that eventually. I actually don't know exactly how it works in Python. I know more or less how it works. I've done it in Java. I've done it in C#. So no matter what language, there's going to be test frameworks and stuff. But all right, well, I think we'll end right around here. I got to go to work. But all of this stuff important, just it's good information to have. Now, in terms of resources that you can use to look at this, just Google it. I mean, you will find good examples of all of these things. You know, you can find some of the kind of paid resource sites might have like more formal instructional videos on it. You know, like there's a lot of websites. It's a good thing. I like having variety and options. There's a lot of like professional development websites that'll have like targeted specific videos for specific topics, you know, like maybe working with a database system, you know, like a specific database provider or a specific framework like React or Angular or ASP.NET. That's an API for the backend and written in C#. Or all of these things, and you'll be able to go find specific tutorials. A lot of them will be paid, but you might find some for free. And, you know, so breaking down, if you want to go read more, I would read about unit tests and integration tests. And I think there's even another level called system tests. So I would read about testing. I would read about pseudocoding and how you break problems down, right? The benefits to doing so, when doing so is more complicated, and then research test-driven development specifically, and this red-green refactor. I don't know if that's the exact terminology. That's how I always think about it. And think about this idea of testing your code before you write it.
Okay. Okay.
All right. Well, by the way, you don't have to spend lots of time on this either. I don't want to like overwhelm you with informational deluge so that you never program. What you should be working on now, before I sign off, is practice as well. Because all of this stuff that I'm mentioning here, people will be impressed if you know this coming into a job, but this isn't your job. Your job is actually coding, right? I mean, I don't want to say that actually. This is your job too, but on top of coding. But you need to be able to do the former before you can even get to this, right? Feel free to message me with stuff if you get stuck. But other than that, I don't think we'll formally meet here for a while. And suppose we'll talk more about that later. So that's where we'll cut for today. And when we next pick up, we will probably, formally, we'll probably either be going over problems to these questions or we'll be starting some of the more advanced stuff here.
So you were going to give me or mark out problems I should work on that website, right?
And I will, but we have plenty of problems here in this file that you still haven't.
Yeah, I'll work on these ones first.
Yeah,
work on these ones first. But given how much we have to cover, I want to get through everything as fast as I can, so we can get to the rest of it.
The rest of the stuff being what? This stuff down here?
No, the advanced topics we have yet to cover. Tools
I mean, I don't know exactly what your expectations are, but I was thinking we'd practice for at least a couple of weeks here.
Okay, I thought the practice thing just has to do with how many problems I solve rather than how long, because if I work on a lot of problems in a short time, would that not also do the same thing as working on some problems over a long time? Like if I were able to work on a lot of problems in a week.
Well, I mean, it really depends. It really depends on how fast you start getting. Okay. So it's not a matter of time. Like it's not even like you can even do 50 problems. And if you're not learning things from the process, you may not be any better developer, right? It's not just the number of problems. And, I won't be a perfect judge of exactly where you are, but the goal is for you to be comfortable with this. And a level of comfort is measured in how quickly you can take a problem like the ones that we're doing here and how quickly you can take a problem and solve it. So, like I said, from a production standpoint, most of the things that I've written for you here will take me less than 5 minutes to write, probably only a couple. And until you get to that level, now, of course, you're not going to be quite at the same level as people who have years of experience and stuff, but you need to get closer to that. If it still takes you 20 or 30 minutes, well, that means that you still need more practice. Do you see what I'm saying? And I don't want us to try to run before we can walk, so to speak. And so that's why I would like for us to spend some time practicing all of the things that we've talked about here, because I promise you, when I go start talking about classes and inheritance and generics and Lambda functions, you're gonna have to start worrying about all this stuff too. Like you're not going to be able to do that well and effectively unless everything else is already easy for you. It's going to be too much. So I'm not going to put arbitrary bounds. I mean, obviously we'd like to go faster than not, right? We'd like to be able to know everything so that we could actually get employed faster than not. But I don't think you can get around the level of, approaching the problems and then being able to solve them correctly, do the right thing in a timely manner. You can't not do that step. Like you can't skip that step. That's important before we move on. That's it. So I'm not going to arbitrarily set a time limit of a week or two. We'll see. I mean, if you blow through stuff, I'll keep giving you more problems. And if I feel like, me giving you more problems, like you got it. Like I don't need to give you more problems, then I won't. But we've actually already covered a lot of stuff. If you've gone back through and you've looked at everything we have here, we've covered, a whole bunch of stuff, not just loops, but also dictionaries, lists, user interaction, reading stuff in from a file, you tell me if there's any specific thing you're interested in, and we can do examples along those lines. But I truly think if you go back and you understand absolutely everything here that we've done, and you can do it and you can replicate it, and it's easy for you and you can make functions, you're in pretty good shape, right? Especially considering we've only been doing this for a couple of weeks here. But I want to make sure we get there is all.
Okay. That's fine with me.
All right. Well, we'll check back. We'll see. Like I said, I'm not going to arbitrarily. That's, you're correct. Something that really annoyed me about college was it wasn't, well, let's work on something until you get it. It was, we have a schedule that's unchanged and unflexing. And if you don't like it, too bad, so sad, right? We're not going to do that. Of course, we're not going to do that, right? If you've got it, we'll move on. But I want to make sure we do get it before we move on. I'm not going to harp on the point any more than that. That's it.
Okay.
Because the advanced topics will depend on you having a strong foundation on the less advanced ones. And until I'm sure that we're ready, I'm just not going to have us move. Make sense?
Okay.
Yep. Okay. Well, I really do have to go to work, so off we go.
Okay. Yeah.